Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here is a problem for today. It's a practice problem for exam FM on financial mathematics. Jack inherited a perpetuity due with annual payments of $1,500. He immediately exchanged the perpetuity for a 25-year annuity due having the same present value. The annuity due has annual payments of fx. My apologies. All the present values are based on an annual effective interest rate of 10% for the first 10 years and 8% thereafter. Calculate x. So comparing the two would be very easy if the interest rate were the same all the time, because one very important thing to remember is that if you have a level perpetuity due, its present value is the annual payment divided by the interest rate, by the discount rate, corresponding to the interest rate that you're working with. For perpetuity immediate, it's the annual payment divided by the interest rate, but for the perpetuity due, it's the annual payment divided by the discount rate corresponding to the interest rate that you're working with. But instead, we have a 10-year annuity at 10%, and it's an annuity due. So its present value is 15,000 times a double dot angle 10 at 10%. And then 10 years later, we have a perpetuity due of 15,000 per year at 8% interest rate. And the present value at that time, 10 years from now, of that perpetuity would be 15,000 divided by the discount rate corresponding to 8%, which would be 0.08 divided by 1.08, by the way. That discount rate, D, 8%, that's 0.08 divided by 1.08. But it starts 10 years from now, so its present value today is the value 10 years from now times 1.10 to the negative 10. So this expression that you see in the first formula on the left-hand side, that is the value of the perpetuity due. And that a double dot angle 10 at 10%, that's 1 minus 1.1 to the negative 10 over d corresponding to 10%. So we write it out this way. And then d corresponding to 10% is 0.10 divided by 1.1, so 1 over it is 1.1 divided by 0.10, and d corresponding to 8% is 0.08 divided by 1.08, so 1 over it is equal to 1.08 divided by 0.08. So then we have all these written out. We can just take 15,000 times 1 times 1.1 over 0.10. Well, that's 15,000 divided by 0.10. That's actually 150,000. So what this becomes is that's just 150,000 times 1.1 minus 15,000 divided by 0.10, so 150,000 times 1.1 divided by 1.1 to the 10th, plus the product of this multiplication of 15,000 times 1.08 and then division of it by 0.08, which becomes actually 15,000 divided by 0.08 is just 187,500 times 1.08, and then the whole thing is divided by 1.1 to the 10th. Now you can calculate all these, and it comes out to be approximately 179,457.87. And this is exchanged for 15-year annuity due of x paid annually having the same present value. It is an annuity at 10%, annuity due, for the first 10 years, and then it's an annuity due for another 15 years at 8%. So X is multiplied by the present value of a unit annuity due over 10 years, plus present value of a unit annuity due payable over 15 years, however payable 10 years from now. So to get the present value, you need to divide it by 1.1 to the 10th. But that expression, x times those two added up, is equal to the present value of the perpetuity. And this is an equation in x is equal to 179,457.87 divided by a double dot angle 10 at 10% plus a double dot angle 15 at 8% divided by 1.1 to the 10th, and then we calculated with a calculator. It would be approximately 17,384.14. And that's answer B. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries and belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.